All right, this is a review for the first quiz in our trigonometry class. We're going to go through every question step by step and explain how to do them. You need to know that if the question is asked in degrees, then you need to answer in degrees. If the question has the angle in radians, then your answer needs to be in radians. You need to simplify all fractions. You also need to rationalize all the square roots that end up on the bottom. So let's go ahead and start with number one. Find the two angles, supplementary angles with measures of 2x plus 40 and 4x plus 32. So really it's just testing the definition of a supplementary angle. So you have the first angle, 2x plus 40, and the second angle, 4x plus 32. If we add them together, supplementary angles should add to 180 degrees. We're going to go ahead and combine like terms. So this is 6x plus 72 equals 180. You're going to subtract 72 from both sides, giving you 108, and divide by 6, giving you x equals 18. This is not your final answer. You still have to find the angles. So we'll go ahead and plug them back in here and in here to find the two angles. The first angle, that would be 2 times 18 plus 40, and it should work out to be 76 degrees. The second angle, that would be 4 times 18 plus 32, and that is 104 degrees. Of course, make sure that they still add up to 180, which is what supplementary angles are supposed to do. Number two, in a circle with a radius of 9 inches, the arc is intercepted by a central angle with a measure of 130 degrees. So my radius is 9, and this angle over here is 130 degrees. We need to find the arc length and the area of the sector. The arc length has a formula of, not A would be the area. Arc length is S equals R theta, but theta has to be in radians. I'm actually going to do this all on one line. So my radius is 9, my theta is 130, but I have to convert it to radians, so pi divided by 180 degrees. Some simplification is in order. The 130 and 180, you can easily reduce them by 9, so I'll write it one more time. 13 pi over 18. And then if you notice that 9 and 18 can also be reduced, this is a 1, this is a 2, and your answer is just 13 pi over 2. It's in inches. We're not going to simplify it anymore. We don't have calculators, so leave it as a fraction. And then the area. The area formula is 1/2 r squared this time times theta. Theta still needs to be in radians. So you have a couple of options. You can convert it separately, or you can do it in one line, just like I did. I'll go ahead and convert it kind of on the side over here. So that's 130 times pi over 180. So it really is just 13 pi over 18. There's not much else you can do here. So let's go ahead and plug it in. 1/2 times 9 squared times 13 pi over 18. Okay, couple of things. You can just go ahead and multiply it all out and reduce at the end, but it will be a little bit harder that way. So 18, if you notice that 18 and again 9 squared have a factor in common. 18 divided by 9 is 2, and 9 squared is 9 times 9, so just the square goes away. So now we have 9 times 13 pi, 2, 2, and 9 times 13 is 117. Pi is still there, and it's over 4. Area is measured in the square inches. All right. Coterminal angles, so find the angle between 0 and 360 or 0 and 2 pi that is coterminal to the given angle. So part A is given in degrees, so my answer is going to be in degrees. And all you have to do here is either add or subtract 360 degrees in order to get an angle that's between 0 and 360. Since 560 is bigger than 360, we're going to subtract 360 degrees. You'll get 200 here, and that is your final answer. We'll go ahead and do part B. So again, you start with subtracting 360 degrees. Well, on that one, it's not going to be quite as fast because once we subtract 360 from 800, we're actually going to get 440 degrees over here, which is bigger. It's not in this interval. It's bigger than 360. So go ahead and subtract 360 one more time. And now you'll get 80 degrees, which is between 0 and 360. Now for the radians, part C is negative. So this time we are going to add. We're not going to add 360. We're in radians now, so we're going to add 2 pi. Common denominator, pi over 7 plus 14 pi over 2. And that would be, well, not 2, 14 pi over 7. We have to have the same denominator. So now go ahead and subtract those. Negative pi plus 14, that's positive 13 pi divided by 7. And that is the coterminal. Is it between 0 and 2 pi? Yes, it is, because 14 pi over 7 is 2 pi. 13 pi over 7 is less than 2 pi. On 19 pi over 3, the same kind of setup. We'll go ahead and subtract, though, because 19 pi over 3 is bigger than 2 pi. We're going to subtract 2 pi. Same denominator. Minus times 3. 2 pi times 3 over 3. So this is 6 pi over 3. 19 minus 6, that's 13 pi over 3. Now, now we have to decide whether or not it is in between 0 and 2 pi. Well, kind of on the side here, here's your thought process. 2 pi with a denominator of 3 is 6 pi over 3. We got 13 pi over 3, so that's way bigger than 2 pi. So we have to keep going. And I'm going to subtract, instead of 2 pi, I'm going to subtract 6 pi over 3, because again, I need a denominator of 3. So 13 minus 6 will be 7 pi over 3, still bigger than 2 pi, so minus another 6 pi over 3. And finally, we get to pi over 3, which is less than 2 pi. So that's the thought process that you should be taking here. Next one, we had some issues with this one on the homework, so let's review this one again. This is really just conversions. A wheel of radius of 15 inches is rotating at 3 pi over 5 radians per second. What is the linear speed and the angular speed in revolutions per minute? So the linear speed, well, let me write down what we have. R equals 15, and this is inches. And we have omega, which is 3 pi over 5, but it's in radians per second. We'll have to convert it to revolutions per minute in a minute. We'll start with the linear speed because our omega is in the correct units to find the linear speed. V equals, and that is R omega, where omega has to be in radians per second. So this is just 15 inches times 3 pi over 5 radians per second. 5 and 15 will reduce by 5. This is 1, this is 3. So this is just 9 pi inches per second. So that is done That is your linear speed. Now we need to convert the angular speed in revolutions per minute. So we have 3 pi over 5, and it's in radians per second. We need to multiply that by 1 revolution for every 2 pi radians, and then multiply it again by 60 seconds for 1 minute. So we're setting up a dimensional analysis problem. Let's see what cancels. Seconds and seconds go away. Radians and radians go away. So what we have left is revolutions on top and minute on the bottom, which is what we need. Now let's look at the numbers. We have 5 times 2, that's 10, and 60 is divisible by 10. So I'm going to get rid of the 5, get rid of the 2, and that would be 6 right here. The pi's go away, pi and pi. So all I have left is 3 times 6 on the top, which is 18 revolutions per minute. So RPM. All right. Number 5, find the lengths of the missing sides A and H of the right triangle. Well, that should say B, because A is given. This should say B. And H of the right triangle, where sine A is 2 over 3, and side A is 4. So we are working with this angle right here. Okay, here's what you're going to do. You're going to say, okay, sine of that angle A is opposite over the hypotenuse, which means it's A over H, which also means that it's 2 over 3 like this, because it's given. Sine A is 2 over 3. We're also given that A is 4. So you're going to plug in that 4 for A, make another proportion. That would be 4 over H equals 2 over 3. So that's 4 times 3, that's 12, equals 2 times H, which means that H is 6. 12 divided by 2. We don't have units here, so just 6. Now side B, A squared plus B squared equals H squared. That is just a Pythagorean theorem. A was 4. B we don't know. H was 6. So that's 16 plus B squared equals 36. So B squared equals 20, which means that B is the square root of 20. You should simplify this. 20 is 4 times 5. So 2 square roots of 5. All right. Use this figure to evaluate the 6 trigonometric functions of the angle A. Rationalize the denominators, or obviously reduce all fractions if needed. So let's go ahead and look at this one. So on this one, we're given the hypotenuse and we're given the one of the sides. We are not given the other side. We need to find side A. So we'll go ahead and do that first. So 7 squared equals A squared plus 5 squared. So 49 equals A squared plus 25. Subtract 25 from both sides. This is 24 equals A squared, which means that A is the square root of 24. Yeah, you should reduce that. This is 4 times 6. So 2 square roots of 6. Okay, now that we know that, we can go ahead and do the rest of the problem. Sine of A, that's opposite over the hypotenuse, which means opposite is side A, 2 square roots of 6 over the hypotenuse, which is 7. So that is sine A. Cosine A is adjacent over the hypotenuse, Adjacent side is 5, hypotenuse is 7. I'm going to go to tangent now. Tangent A is opposite over the adjacent. Opposite side is 2 square root of 6, and adjacent side is 5. Cosecant, so our reciprocal identities. Cosecant is 1 over sine. This one a little bit harder on this one, so this is 7 over 2 square roots of 6. We do need to go ahead and rationalize the denominator. Couple of steps here. 7 square root of 6 over 2 times 6. So this is 7 square roots of 6 over 12. Secant is 1 over cosine. That one is going to be easier. Cosine is 5 over 7, so 1 over cosine is 7 over 5. Tangent is cotangent is 1 over tangent. You could have done cosine over sine, but 1 over tangent is probably easier. Tangent, so 5 over 2 square roots of 6. Rationalize this, so this is 5 square roots of 6, and on the bottom, that's 2 times 6 again. So 5 square root of 6 over 12. All right, number 7, we're evaluating these functions. We're using the unit circle and odd even identities for the most part. Also probably some reference angles or some coterminals. We'll see. So evaluate exactly, you need to show some work. Both of these angles are on the unit circle, so this one is a little bit easier. The only thing you have to do here is address this negative sign. Cosine is even, so that negative sign just goes away. It's the same as cosine of 5 pi over 6 times sine of 3 pi over 4. From the unit circle, cosine of 5 pi over 6 is negative square root of 3 over 2, since it is in quadrant 2, cosine is negative in quadrant 2, and sine of 3 pi over 4, also in quadrant 2, sine is positive in quadrant 2, so this is positive square root of 2 over 2. So on the top, that's minus a square root of 6, and on the bottom, it's 2 times 2, which is 4. Part B, also both angles are on the unit circle, but it's not the sine and cosine, it's actually reciprocal functions, so we have to address that. So cosecant, that's 1 over sine of 5 pi over 4. Tangent at pi, that is sine at pi over cosine at pi. Now, sine of 5 pi over 4, first of all, it's in the third quadrant, but sine of 5 pi over 4 is square root of 2 over 2. So this is 1 over negative square root of 2 over 2 times sine of pi is 0, cosine of pi is negative 1. So this whole fraction is 0. 0 divided by any number is 0. This fraction will gets multiplied by 0. Oh, let me just do this. This whole thing is 0, and anything times 0 is still 0. So the overall answer is 0. Part C, so now we're in degrees, still on the unit circle. Probably some coterminals. That's a little bit easier than anything else. Let's go ahead and address the negative inside of a sine. Sine is odd, so this will be equivalent to tangent of 450 minus sine of 270. So what does that mean? Well, 450 is not really on the unit circle, but if we use the coterminal angle, so if we subtract the 360 60 degrees, then we should get to be on the unit circle. So tangent of 450 is equivalent to tangent of 450 minus 360 degrees, minus, that's in between now, minus sine of 270. 270 is already on the unit circle, so I don't have to do anything there. So this is tangent of 90 degrees minus sine of 270 degrees. Now tangent, think about that. Tangent is sine over cosine, so let me go ahead and do this. Sine of 90 over cosine of 90. This is where your issue is going to come in. Once in a while, you get a trick question like that. Sine of 270 degrees, by the way, is -1. So I'll go ahead and write that down. But what we have here is sine at 90 degrees is 1, but cosine at 90 degrees is unfortunately undefined, or it's 0. So 1 divided by 0 is going to be undefined. And since at least one answer was undefined here, the whole problem is going to be undefined. I doubt I'll put anything like that on the quiz, but it does happen on the homework once in a while. So let's go ahead and look at secant and cosecant. Let's go ahead and deal with the odd even identities. First, secant is even and cosecant is odd. So with the secant, we don't have to worry about the negative sign. This is just the same as secant of 720. Cosecant, though, because it's odd, that negative is going to come in before the function. 50 degrees. Didn't fit. Okay, now let's change into the coterminal angles. I think that's the easiest. Well, 720 is actually 360 plus 360, so secant, I'll go step by step, 720 minus 360 minus cosecant of 450 minus 360. Coterminal angles is what I'm doing here. So that would be secant of 360 degrees minus cosecant of 90 degrees. Secant is 1 over cosine of 360 degrees. Cosecant is 1 over sine of 90 degrees. Cosine at 360 degrees is 1, so it's 1 minus 1, 1 over 1. And sine of 90 degrees is also 1, so 1 over 1. Overall, that's 1 minus 1, which the answer again is 0. All right. Number 8, sketch the angle in standard position. Find the reference angle, quadrant of the terminal side, and sine and cosine of each angle. So sketch is what we're going to do first. It's a sketch, not an exact graph, so don't worry about it being precise. You do have to show me which direction you were going. This is your angle in standard position of 120 degrees. It is in quadrant 2. Reference angle. Well, that's the distance from the terminal side to the closest x-axis. The closest x-axis is at 180 degrees. We took 120 from it, so 60, well, I mean, you can, if you were calculating it, you would actually do the calculations. You can do it in your head, you don't have to show it to me. 60 degrees is your reference angle. Remember, reference angles are always positive, always acute. And then sine and cosine, that is from the unit circle. Sine of 120 degrees from the unit circle, square root of 3 over 2. Cosine of 120 degrees is negative 1/2. 540 degrees. Let's graph it first. Right, 540 degrees is more than one revolution. So we start right here, we do 360. We're going to keep going. 360 plus 180 is actually 540. So the angle will stop right there. Then let's go ahead and do the reference. This is about this in the lecture, but the reference angle when you are on the x-axis is 0 because by definition, it's the distance between the terminal side and the closest x-axis. Well, we are on the x-axis, so there's no distance, it's 0. So 0 for the reference angle. I did not put the quadrant down because there is no quadrant. It is on the x-axis. You can go ahead and put that down, but it is obvious from your drawing also. So reference angle is 0, which means that sine of 540 degrees is the same as sine at 0 degrees, which is 0, of course. And then cosine of 540 degrees. Well, on this one, make sure that you're kind of looking at where the angle is. It's the same as cosine of 180 degrees, which is -1, of course. Now with radians. So 7 pi over 6 with radians. Graph it over here, x and y. So 6 pi over 6 is pi, and we have 7 pi over 6, so we have to go a bit further. So right here is your angle. And now, let's see, quadrant 3, reference. We're in radians, so it is very easy to figure out the reference angle. It's just pi over 6. So sine of 7 pi over 6 is -1/2 quadrant 3, and cosine of 7 pi over 6 is negative square root of 2. Oh, square root of 3, not 2. Square root of 3 over 2. Again, that is from, all of these are from the unit circle. Fifteen pi over 4, lots of revolutions around the, let's keep the colors consistent. Let's do black for the x and the y axis. All right, so the first revolution, we're in radians. So the full 2 pi would be 8 pi over 4. So 2 pi equals 8 pi over 4. I'm just trying to teach you how to graph this. So we're going to go ahead and go full revolution. That's 8 pi over 4. And then we have another 7 pi over 4. Not quite the full revolution, but close. This is your angle. Quadrant 4. Reference. Pi over 4. Sine of 15 pi over 4. That will be the same as sine of pi over 4, but with the adjustment for the quadrant. Sine of pi over 4 is square root of 2 over 2, but we're in quadrant 4. Sign is negative in quadrant 4, so don't forget to add a negative sign. Cosine of 15 pi over 4. That would be the same as cosine of pi over 4. And cosine is positive in quadrant 4, so square root of 2 over 2. All right, word problem. So lightning rod on top of a building from the location 500 feet. From the base of the building, the angle of elevation to the top of the building is 36. Same location, the angle of elevation to the top of the lightning rod is 40. Find the height of the lightning rod, and we are doing just the setup since we don't have calculators. Here's your antenna. We have location right here, 500 feet away. Angle of elevation to the top of the building is 36. Angle of elevation to the top of the antenna is 40. We are going to label the height of the antenna H and the height of the building X. This is a right triangle, so we'll go ahead and work with it. So the blue triangle, we have tangent of 36 degrees. So this triangle right here, the blue one. Tangent is opposite over the adjacent. Opposite side is x, adjacent side is 500. So that means that x equals 500 times tangent of 36 degrees. Then we have this big triangle right here. Still a right triangle. This triangle has tangent of 40 degrees. Opposite, which is x plus h, divided by 500. So x plus h equals 500 times tangent of 40 degrees. Now I'm solving for h, so what I can do is plug in this for x. So 500 tangent 36 degrees plus h equals 500 tangent 40 degrees, and then subtract stuff from both sides to just get h. 500 tangent of 40 minus 500 tangent of 36. This is as far as you can go without a calculator. Okay, a little bit simpler problem. A ladder is leaning against the side of the building. So we still have a building. Have a ladder. Let's see, 14 feet above the ground. So this side right here is 14. Oop, 14. Making an angle of 57 degrees with the side of the building. 57 degrees. How long is the ladder? Okay, X for the ladder. And we don't know what the other side is. That's okay. Okay, so here's what we know. We know an angle. We know the side that's adjacent to that angle, and we need to find the hypotenuse. So side that's adjacent and the hypotenuse is a cosine. So cosine of 57 degrees equals adjacent, which is 14, over the hypotenuse. So x times cosine of 57 is 14, which means that x equals 14 divided by cosine of 57. Again, without a calculator, this is as far as you can go. All right, number 11, just quick odd and even identities. Answer the following. You do need to explain your answer, but the explanations are fairly easy. So tangent is odd. So tangent of negative theta equals negative tangent of theta. So negative, and tangent of theta is this number right here. So negative and then negative 3.4. So it's just 3.4. Secant is even because secant is 1 over cosine. So secant of negative theta is the same as secant of theta, and it's just 0.78. Okay, basic identities to rewrite the expressions, generally as a single function or maybe a number sometimes. We have cotangent over tangent, and then we have times sine squared. So generally you want to get everything in terms of sines and cosines and see what cancels out. Cotangent is cosine over sine. Tangent is sine over cosine. Times sine squared. And now the two-story fraction, I'm going to break it up. So cosine theta over sine theta times cosine theta over sine theta. You flip the bottom fraction, the one that's in the denominator, times sine squared theta. Well, hopefully you can already see it. So on the top, cosine times cosine, that's cosine squared theta. On the bottom, sine times sine, that's sine squared theta, times another sine squared theta. Those two will cancel, leaving you with just cosine squared theta. Single trig function, you're good. Secant and sine. Secant is 1 over cosine times sine. Well, that's just sine theta over cosine theta, which is tangent. So you do have to memorize the basic identities. This is also basic identities, but this is also using the complementary angle theorem. So part A, if you just remember the main form of the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. Well, since it doesn't matter what theta is, as long as it's the same theta, sine of 20 degrees, sine squared of 20 degrees plus cosine squared of 20 degrees is just 1. It's literally this theorem with when theta is 20. So just 1, you just have to recognize it. Let's try this next one. Cosine of 10 degrees, sine of 80 degrees. Well, little bit of critical thinking over here. So we're going to rewrite this cosine of 10 degrees in terms of its cofunction, which is sine. So cosine of 10 degrees is the same as sine of 90 minus 10 degrees. I'm hoping it's already obvious. Sine of 80 divided by sine of 80. That's just 1. Part C, we have sine of 80 and cosecant of 80. Let's go ahead and change it all into sines. Sine of 80 degrees times 1 over sine of 80 degrees. Once again, sine on the top, sine on the bottom is just going to cancel out, and it is just 1. Now let's try secant and cosecant. Once again, the complementary angle theorem and cofunction identities is what we're using here. So let's go ahead and rewrite this. So secant of 28 degrees, I'm going to write it as a cosecant. Cosecant of 90 minus 28 degrees minus cosecant of 62 degrees. Well, 90 minus 28 happens to be 62. So you now have cosecant of 62 minus cosecant of 62, which is 0. All right, use one of the forms of Pythagorean identity to find the indicated value. So you cannot use any other approaches here. You have to use the Pythagorean identity for trig. If tangent theta is 3 and the terminal side of theta is in quadrant 4, find secant theta. Let's see, tangent theta is 3. There should be a negative sign in here. In quadrant 4, tangent is negative, so it should be negative 3. So let's go ahead and add a negative over here. I need to fix that on the actual paper. Let's go ahead and start with a Pythagorean identity for tangent. If you forgot it, derive it real quick, but I'll go ahead and just write it down. Tangent squared theta plus 1 equals secant squared theta. Tangent is negative 3 squared plus 1 equals secant squared theta. So negative 3 squared is 9 plus 1 is 10. And then take the square root. Secant theta is the square root of 10. Now, in quadrant 4, secant is 1 over cosine, and cosine is positive in quadrant 4. So you don't have to add a negative sign here. Secant is positive in quadrant 4. And then part B is dealing with sines and cosines. So this is our basic form of the Pythagorean identity. Given that sine of t is 1 over 5 and the terminal side of t is in quadrant 2, find cosine of t. So this one is just sine squared t plus cosine squared t equals 1. Sine is 1 over 5. We have to square that. Plus cosine squared t equals 1. So 1 over 25 here plus cosine squared t equals 1. So cosine squared t equals, I'm going to rewrite 1 as 25 over 25 minus 1 over 25. So cosine squared t is 24 over 25. You have to take the square root. Square root of 24 over 25. The denominator is a perfect square. So just 5 in the denominator. And then square root of 24. 24 is 4 times 6. Square root of 4 is 2. Square root of 6 stays there. Now, let's check the quadrants. We're in quadrant 2. Cosine is negative in quadrant 2, so make sure to actually add a negative sign before boxing in your final answer. Number 15, suppose that P has a coordinate of negative 3 over 5 and 4 over 5, and it's a point on the unit circle that corresponds to the angle theta. Find the exact values of sine, cosine, and tangent. It does help if you plot that point. It doesn't have to be exact, just the quadrant is what we're looking for. X and Y. So negative on the X, positive on the Y, that would be quadrant 2. So somewhere right here would be your point P. And your angle is this angle right here. Now, since we're on the unit circle, sine theta, this is theta, would equal the Y coordinate, which is 4 over 5. And cosine theta would equal the X coordinate, which is negative 3 over 5. So you already answered 2 out of 3 questions. Now, tangent theta, you do have to plug in. Tangent theta would be sine theta over cosine theta. And that would be 4 over 5 divided by negative 3 over 5. Do not leave this unsimplified. 4 over 5 times negative 5 over 3. So this is negative 4 over 3. That's not the only way to do this problem. If you are using a different method and it's working, you're getting the same results, by all means, use a different one. All right. Now into chapter 6. Find the amplitude, phase shift, midline, and the period of this function. I gave you two different functions, one with a sine, one with a cosine. The formulas are the same for both, so let's go through this step by step. Amplitude. So actually, let me do this. Y equals A sine of bx minus c plus d. This is the general form of these equations. Cosine bx minus c plus d. Okay. Amplitude is the absolute value of A. It's the absolute value of 3, which is just 3. Midline, that's D. You can just put -5. You can put y equals -5. It's all the same thing. The period has a formula that would be 2 pi over b. 2 pi is the fundamental period for sine and cosine. B in our case is pi. So 2 would be your final answer. Phase shift, that's C over B. Now our C is pi over 2, positive pi over 2, and pi is my B, so that's pi over 2 times 1 over pi, essentially. Pi's cancel out, 1/2 would be your phase shift. Now, why is it positive instead of negative? Well, that's because, let me do this. That's because this x goes with that minus sign, just like the formula does, right there. Okay. Now let's go into part B, the amplitude. Absolute value of -2, so just 2. Midline, this one, D equals +4, not negative. Period, still 2 pi over B, so 2 pi over 3. Can't simplify, that's just 2 pi over 3. Now phase shift. Now on the phase shift, we have a plus right here, but it is not really a plus. I'll rewrite it. -2 cosine 3x minus, and then negative pi over 2. And then +4. Okay, so really C is negative on this one. C over B, C is negative pi over 2 divided by 3. So negative pi over 2 times 1/3, negative pi over 6. We're not graphing these, we're just identifying all the parts of the function. Number 17, though, we are graphing them. So let's go ahead and start with the simpler ones. On the quiz, you'll have the simpler ones. On the test, we'll have some more complicated ones. Graph at least 2 periods of the given function and state the x-intercepts. So we'll go ahead and start with the graph. So it helps if you identify the amplitude and the period. 2 pi over b, which is 1/2. So that's 2 pi times 2 over 1. Which is 4 pi. When the period is 4 pi, the step size, well, that's just 4 pi divided by 4, so pi. And yeah, I think that's it. Let's go ahead and label. So this grid already includes labels, but that doesn't mean that they will work for your problem, so adjust the labels accordingly. For us, we need to graph 2 periods, and it only goes, my labels only go to 4 pi. One of my periods is 4 pi, so I actually do have to adjust this. So this has to be 4 pi, and this has to be 8 pi, otherwise it's not going to be right. So let's see, then this is 2 pi. No, and this is 6 pi. Now, my step size is pi, which is right here, and that means that it is 2 squares for me. You could choose to label it where your step size is 1 square, and that, if that makes more sense to you, by all means, go ahead and do that instead. On the y-axis, my graph is going to go up to 2 and down to -2. Let's go ahead and graph it now. This is a sine function. You need to know that a sine, when we don't move it left and right, starts at 0, 0. Then it goes into the maximum after one step, which for me is 2 squares. Then it goes into the x-intercept, then into the minimum, x-intercept, maximum, x-intercept, minimum, x-intercept. We'll go ahead and connect the dots, smooth curves, guys. X-intercepts, let's go ahead and label it here. That would be 0, 0, 2 pi, 0, 4 pi, 0, 6 pi, 0, and 8 pi, 0. I believe on the quiz I just asked you to label them on the x-axis without listing them separately. I'll add an arrow over here. All right, let's go ahead and graph the cosine function. So this one is reflected. A is 1, but it is reflected. That's what a negative in front of it means. It's the graph of the function is reflected over the x-axis, but the amplitude is still 1. We have a period of 2 pi over 2, so just pi, which means my step will be pi divided by 4. Let me label this, and then we'll figure out how many squares that is. I am actually going to stick with their labeling. This is pi, this is 2 pi. So that means that pi over 4, that's just 1 square. Okay. I will put more labels down in a second after I graph this. So for me, this is a cosine function. Cosine usually starts at a maximum, then goes into the x-intercept, then minimum, x-intercept, maximum, x-intercept, minimum, x-intercept, maximum. Now, mine is reflected, so the points that are on the x-axis, they will stay on the x-axis, but the other ones, the maxes become mins, the mins become maxes. So this max will go right here into the min. This one will go right here. This one will go right here. 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 I'm going to erase the blue ones. I'm not going to use the blue ones. Those were my placeholders for reflection. And I'll go ahead and connect the purplish dots. There you go. So if your step size is 1 square, your graph just looks a lot smaller, but that's okay. Now I have not labeled the x-intercepts yet, so let me go ahead and label it. So my step size is pi over 4. So this first one is pi over 4, which means this one right here, that's 3 pi over 4, 1 less than pi, which means that this one right here, that's pi plus pi over 4. So this one is 5 pi over 4. And then this one right here, it's 1 less than 2 pi, which is 8 pi over 4. So this one is 7 pi over 4. So the x-intercept would be at pi over 4, 0, at 3 pi over 4, 0, at 5 pi over 4, and 0, and at 7 pi over 4, and 0. Okay. Write the equation of the graph. No horizontal shift, no phase shift on these. You just need to figure out the equation of the graph. This first one, it looks like our midline is actually our x-axis, so the graph is 2 steps up from the x-axis is the max, 2 steps down from the x-axis is the min. So my amplitude and my midline can easily be determined. Midline is 0. Amplitude is 2. 2 steps to the max, 2 steps to the min. Now let's determine whether it's a sine or a cosine. So if you know the parent function sine without the horizontal shift will start at 0, 0. So that's great. This is a sine function. There's no phase shift, so no C, but we do need to figure out B. In order to figure out B, we need to know the period of this function. So from 0 to here, that's 8. You also can figure out the period from max to max, but then you have to subtract the two values. So this is 2, this is 10, so that would be 10 minus 2, which is also 8. So my period is 8. It's also, by definition, 2 pi over b, which means 8 times b equals 2 pi, which means that b is 2 pi over 8, or pi over 4. All right, we have everything to write down the equation of this function. Oh, I did not put down the general one. That's y equals a sine bx. We don't have c plus d. So we'll go ahead and use that. Y equals, a is 2. This is a sine function. B was pi over 4. And d was 0, so I'm not gonna put plus 0 down. We don't need it. And then let's try this one. So obviously on this one, the midline is not at the x-axis. So figure out where the midline is. It's not too difficult on this one to figure out. It's right here. So D is 3. Then the amplitude, so from the midline, how many steps up, how many steps down? That looks like just 1 here and 1 here. So A is 1. Then we need to figure out whether it's a sine or a cosine. If it was a sine function, it would have started right here. It does not. It starts at the maximum. So this is cosine. Hey, what else do we need? We need a period. So on the cosine, the period is pretty easy to figure out. This is at 0. So go to the next max. The next max is at 4 pi over 3. So the period for this function is 4 pi over 3, but also by definition, it's 2 pi over b. Cross multiply, so that would be 4 pi times b equals 6 pi. So b equals 6 pi over 4 pi. Pi's cancel out, and 6 and the 4 can be reduced by 2, 3/2. Okay, I think we have everything that we need. Y equals, A is 1. You don't have to put 1 down. So cosine B 3 over 2 times x plus D, which is 3. All right. This is the end of the review. Hopefully it will help you with the quiz.